Example 3. A particle moves along the x-axis with a velocity v of t given by the table, at several different times in t seconds. Determine the distance traveled on the interval 0 to 5 by evaluating the integral 1 to 5 of r of t dt. Now this example might look familiar. This was back from a previous section where we used LRAM, RRAM, and MRAM to approximate the distance traveled. So now we're going to use the trapezoid rule to show a better approximation of that. I do want to make one side note, and that is that we've seen when distance is both positive and negative because you could be moving forward and backwards. However, displacement is the positive minus or plus the negative. So if I move forward and then backward, my displacement is going to be less than my total distance. Notice how all of my v of t values are positive. So because of that, the displacement is going to be equal to the distance traveled. Alright, so now to use the trapezoid rule. So using the trapezoid rule, we know that the equation is going to be h over 2 times y naught plus 2y1 plus 2y2 plus 2y3 plus 2y4 plus y5, where the height is equal to b minus a over n. So it might be helpful to go back to the table and identify your y naught through y5. This one's y naught, y1, y2, y3, y4, y5. This is your x naught, x1, x2, x3, x4, and x5. So using the trapezoid rule, we just have to plug everything in. And you get that t is equal to, we got to find h, so let's go find h. H would be 10 minus 0 over 5, so that's going to be equal to 2. So you get 2 divided by 2. 0 plus 2 times 5 plus 2 times 12 plus 2 times 21 plus 2 times 25 plus 28. And this is going to be equal to 154 feet. So when we compare that with the LRAM and the RRAM, the LRAM was 126 feet, and the RRAM is 182 feet. You can see that the trapezoid method is much more accurate than LRAM and RRAM.